So let's do an example of direction cosines since we're already here. And let's find those angles and let's show that we can satisfy that equality. So remember that the relationship is cosine of alpha is u1 over its magnitude. Cosine beta is u2 over its magnitude. And cosine gamma is u3 over u's magnitude. So clearly the first thing we need to do is get u's magnitude. So to do that, we'll do it because we've done it a bunch of times already. It's the square root of each component squared, or the sum of each component squared. Square root of 35. So that tells me that cosine alpha is 5 over the square root of 35. Which I guess we could represent as the square root of 5/7 if we wanted to. Cosine of beta is 3 over the square root of 35. And cosine of gamma is going to be -1 over the square root of 35. So those are your direction cosines. Now those angles, they're going to be the inverse cosines. And they're going to come out to be not unit circle values. So we can say that alpha is the inverse cosine of 5 over square root of 35. Beta is the inverse or arc cosine of 3 over the square root of 35. And gamma is the arc cosine of -1 over the square root of 35. And to verify that this equality holds, then we have to square each of these. So 5 over square root of 35 squared plus 3 square root of 35 squared plus -1 over the square root of 35 squared is 25 over 35 plus 9 over 35 plus 1 over 35, which is 35 over 35, which is 1, which is what we were trying to do. And there you have it. That's an example of direction cosines.